All right, Unit 3, starting off with Objective 1, in behavior exploration. Okay, now a quick note before we start this. In this whole unit, you're going to see a lot of kind of intimidating looking equations, kind of scary looking things here. But one thing you want to keep in mind throughout this unit is that we're not really focusing on the details. In other words, yeah, I got this big equation, but we're only going to look at certain parts of it and focus on certain things like the x-intercepts or the y-intercepts, or in today's case, the end behavior. Okay, so let's dive right in here. Now we got this equation y equals 3 times x to the fourth minus 2x to the third minus 7x squared minus 1. What does that graph look like? Well, who the heck knows, right? That's a big funky equation. But if we type this equation in Desmos, and if you want to, press pause, go punch this in Desmos, and it'll give you an idea. But it's going to look something about like this. It's going to come down here, swoop up a little bit, drop back down a little bit further, and then come up something about like that. Okay, so this is probably a pretty poor drawing of it, but if you look on Desmos, it's going to look something about like that, kind of a droopy W here. Okay, and then we want to focus on a few things. What's our highest degree term? And again, the degree is just relating to the exponents. So what's the highest exponent? Well, x to the fourth is our highest one, and the whole term is 3x to the fourth. Okay, is the coefficient in front of that positive or negative? Well, it's a positive 3, so then it's positive. Okay, and then is our degree, our exponent, even or odd? Well, it's to the fourth power, so then that's even. Okay, and then what does this stuff result in? What does this really tell us? Well, if we look at the end behavior, in other words, how does our graph start and finish? Well, going to the left forever, it's going up. Going to the right forever, it's also going up. So we would say this one goes high to high. That's kind of the language we want to use it. High to high. Because on the left side, it's going up, so it's going high. And on the right side, it's going up, so it's going high. So we would refer to this as high to high. Another example of high to high would be a parabola that opens up. So anything that goes up and up on the two sides, we call that high to high. Okay. Now, what makes this high to high? Okay, and we'll talk about this more throughout the unit. But basically, anytime we have an even number for the biggest exponent, so think like a parabola. Okay, that's either going to be going high to high or low to low if it's opening down. Okay, now it doesn't matter if it's the fourth power, second power, 24th power. Doesn't matter. Anytime this is an even number, it's either going to be high to high or low to low. So anything that's even, think like a parabola. If my parabola is positive, it's opening up, high to high. If it was negative, it'd be opening down. We'll see examples of that later. And of course, parabolas are even. Okay, so any even number, kind of think parabolas. That's kind of what's going to make it easier to figure out the end behavior for you. Okay, so that's number one. And again, that's all we're looking at. So really, out of this whole equation, all we really wanted to look at was that first term there. Okay, the 3x to the fourth part. Okay. All right, same thing on number 2. We got this big equation. What's the graph of that thing look like? Well, I don't know, but if we punch it into Desmos, it's going to look something about like this. It's going to go down, come up, come back down here, do something like that. Okay, so it's going to have these 3 x-intercepts and then a y-intercept somewhere around there. Anyways, it looks something about like that. Okay, now, what's the highest degree term? Okay, now sometimes you got to search for it. It's not always the furthest one on the left, but this time it is again. It's 2x to the fifth. And the key components of that first term is that our coefficient is positive 2, so it's positive. And our exponent, our degree, is odd this time. So when our function is even, whether it's to the fourth power, second power, 10th power, whatever, think of parabolas. When our function is odd, what's the easiest odd function to think of? Well, how about like a line, right, to the first power? Okay, if our line has a positive slope, positive number in front of it, what type of end behavior is that going to be? Well, it's going to be going from left to right. It's going to be going uphill, which is low to high is what we call that. Okay, so our end behavior is going to be low to high anytime that our leading coefficient is a positive number and our exponent is an odd number. Okay, again, relate the even exponents to parabolas, the odd ones to lines, and makes this stuff a little easier to remember. Okay, Anyways, that's number 2. Okay, number 3, let me adjust my camera a little bit. Number 3, again, we got this big scary equation, but really we only want to focus on the first part. That's going to tell us about the end behavior. Okay. Now we do need these other parts for a more accurate graph, and if we punch it in Desmos, we're going to get something that looks about like this. Okay. Again, probably not a good drawing, but it's going to look something close to that. You can check it in Desmos. What's our highest degree term? That's going to be negative 2x to the 4th. Okay, so then our coefficient is negative 2, so it's negative, and our exponent is 4, so that is even. Okay, now what's the end behavior? Don't even worry about the graph. If it's even, think like a parabola, and if our leading coefficient is negative, is that parabola opening up or down? Well, down, so that would be low to low, like this one is here. It's going down on the left and down on the right. We call that low to low. So if all we're caring about is the end behavior, all I really need to look at is that first term. Now that's if it's written in descending order, doesn't always have to be. Okay, but again, pretty easy if we just focus on a few certain parts here. Okay, and then the last one, I got this big equation. What's that graph going to look like? Well, if you punch it in Desmos, it's going to be something like this. It's going to come down. Maybe about like that. That should probably be a little bit more of a rounded curve there. I probably changed direction too quickly, but something about like that. Again, you can check it in Desmos. And then what is our highest degree term? Well, negative 1x to the 3rd, so just negative x to the 3rd, which means it has a negative leading coefficient, and the degree is odd. Okay, now don't even worry about the line. Think about an odd function, so we want to relate that to a line. So think about a line with a negative slope. That's going to be going, downhill, so that's high to low from left to right. So the last one here, we put high to low. Okay, and like it says at the bottom, which I mentioned, note the highest degree term does not necessarily have to be the first term of the polynomial. They can put these 4 terms in any order that they want. It'd still give us the same graph. Okay. All right, but again, if we're looking for the end behavior, well, basically we want to look at just that first term, that highest degree term. Okay. Now, a little bit of a shortcut here is this box, and this is something that you're going to want to be able to recreate. Now, you don't have to memorize it because I can switch the order of these things a little bit. For example, we could draw this box and put the negative here and the positive here, put the odd here and the even here. It doesn't matter, but you want to be able to recreate it. If my leading coefficient is even and positive, well, think even like a parabola, positive leading coefficient, it's opening up, that's going to be high to high. So we're just going to use the arrows instead of writing the words. Okay. What if I have a parabola with a negative leading coefficient? How's that going to open? What's my end behavior going to be? Low to low. Okay. What if it's odd? So think like a line with a positive leading coefficient. So a positive slope, it's going to go low to high. And if my line has a negative slope that's going downhill, it's going to go from high to low. Okay, so if you're able to recreate this little box, again, it doesn't have to be in this exact order, but if you could recreate that box accurately, that's kind of a little cheat sheet for you on a lot of these problems throughout this unit. Okay? All right, for the following function, we want to identify a few things. First of all, what is the degree? Okay, so it's not always the first one. Double check and make sure that this is your highest power. And then, yeah, it is. So it's a 5th degree polynomial, which means it would have 5 answers. In other words, that means it's odd. What's my leading coefficient? Well, negative 1, which means it's negative. And then what's my end behavior going to be? So let's see, it's odd and negative. Odd and negative is going to be high to low. Okay? And that's what they want there. Next, identify the end behavior, justify your answer. Okay, so here's our equation. What's the end behavior going to be? So for the end behavior, do I care about the negative 3x squared minus x plus 3 part? Well, no. If all I care about is the end behavior, I could ignore all that, and I just want to look at the y equals 4x to the third. Okay, so let's see. That is an odd exponent with a positive leading coefficient, so then it should be low to high. Okay, so we can say it should be low to high. Okay, and then why is that? We can put odd degree and a positive coefficient. Okay. All right, the next, if you check on a calculator, so our graphing calculator can just be Desmos. If we punch that in, our graph's going to look something about like this. It's going to come up here, droop back down a little bit, and then come back up. And then, so yeah, that is low to high. And again, double check it on a calculator. Don't just take my word for it. At least check one of them to make sure I'm telling the truth. Okay, but that's what it'll look like, something about like that. Okay. All right, at the bottom here, we want to answer a few questions for each one of these graphs. Okay, so we want to describe the end behavior. Is it an even or an odd degree function? State the number of real zeros, and then real zeros basically just means how many x-intercepts does it have? And then is the leading coefficient positive or negative? Okay, so starting with graph number 1, describe the end behavior. Well, it goes from low to high, so that's easy, low to high. You can use the arrows or you can write the words, doesn't matter. Part B, is it an even or an odd degree function? Okay, remember, even, like a parabola, is either going to be high to high or low to low. So since this is low to high, it's got to be odd. Okay. State the number of real zeros, x-intercepts. So then just count how many times our graph crosses the x-axis. 1, 2, 3 times. Okay. And then finally, is the leading coefficient positive or negative? So when is it low to high versus high to low? Again, check back on your chart if you need to, but the leading coefficient would have to be positive for this one to be low to high. Okay, and then that's that one. 2 more to go on this page. Okay. Next, number 2. What's the end behavior? Well, high to high, so up to up. B, is it an even or an odd degree function? Well, high to high is like a parabola. That's going to be even. Okay, and don't worry about what power. We just know it's an even power, and that's enough. Okay, next, state the number of real zeros, real x-intercepts. So let's see, we cross the x-axis once here, twice there, and that's it, so 2 times. And then the last part is the leading coefficient positive or negative. So again, think like a parabola. When does it open up? When the coefficient is positive. Okay. All right, last one. First of all, the end behavior is low to low, because it's going down here and down there. 2, if it is low to low, then it's got to be an even exponent. So again, like a parabola. Okay. Next, how many real zeros does it have? How many times does it cross the x-axis? We got 1, 2, 3, 4 times. So it's got 4 real zeros, 4 x-intercepts. And then finally, the last part, what is our coefficient going to be? Well, since it's opening down, it would have to be a negative leading coefficient. Okay. All right, so got through those pretty quick. That's the first 2 pages, and then the 3rd page will be in the next video.